we're going to learn how to easily identify leading and trailing zeros. Then we'll count significant figures using 4 simple rules that apply to both decimal and scientific notation. What are leading zeros? Leading zeros are first, before the first non-zero digit. Look at the far left. Is the very first digit a 0? If not, there are no leading zeros. In this example, the first digit is a 0. So we start there and underline or highlight zeros toward the right until we reach the first non-zero number. All of these zeros that we highlighted are leading zeros. The first digit is a 0. It is the only one, but it is a leading zero. The first digit is a 0, and we highlight until we reach the 1. All of these zeros are leading zeros. The first digit on the far left is not a 0. There are no leading zeros here. What are trailing zeros? Trailing zeros are last, after the last non-zero digit. Look at the far right. Is the very last digit a 0? If not, there are no trailing zeros. In this example, the last digit is a 0. So we start there and underline or highlight zeros toward the left until we reach the first non-zero number. These are all trailing zeros. The last digit is a 0. We highlight across until we reach the 1. These are all trailing zeros. Again, the last digit is a 0. When we highlight, we end up with 2 trailing zeros. The last digit here is not a 0. There are no trailing zeros. This single set of rules applies to both decimal and normalized scientific notation. It's all you need to remember in order to count sig figs correctly every time. Exact numbers never count. For example, a balancing coefficient for a chemical equation doesn't count. A prefix multiplier in scientific notation doesn't count. And a defining constant set to be exact in either decimal or scientific notation doesn't count. Leading zeros never count. Identify them, then ignore them. Trailing zeros count if a decimal point is shown. Look for a decimal point, look for trailing zeros. If they are both there, all trailing zeros count. Otherwise, trailing zeros don't count. And finally, all other numbers count. Are there leading zeros? Yes. We will ignore these. Is there a decimal point? Yes, but there are no trailing zeros to consider, so we count all other digits. There are 2 significant figures. Are there leading zeros? No. Is there a decimal point? No. Are there trailing zeros? Yes. But because there's no decimal point, we will ignore the trailing zero and count all other digits. That leaves us with 3 significant figures. Are there leading zeros? No. Is there a decimal point? Yes. Are there trailing zeros? Yes. So we will count the trailing zeros and all other digits, which turns out to be all of the digits in this number. There are 6 significant figures. Are there leading zeros? Yes. Ignore. Is there a decimal point? Yes, but there are no trailing zeros. So we count all other digits. There is 1 significant figure. Are there leading zeros? No. Is there a decimal point? Yes. Are there trailing zeros? Yes, there is 1. So we count the trailing zero and all other digits. There are 2 significant figures. This example shows a terminal decimal point, which is a decimal point added to the end of a number with no other numbers following it. It is used when you want to communicate that the trailing zeros are significant, and this notation completely aligns with our 4 simple rules. Are there leading zeros? Yes. Ignore. Is there a decimal point? Yes. Are there trailing zeros? Yes. So we count the trailing 0 and all other digits. There are 4 significant figures. Are there leading zeros? No, there should never be leading zeros with scientific notation. Is there a decimal point? Yes. Are there trailing zeros? Yes. So we count the trailing zeros and all other digits. That leaves us with 5 significant figures. We followed the same list of rules we've been using and got an accurate count of the sig figs. When you apply these rules to a measurement shown in scientific notation, it turns out that all digits will always be significant. So as a shortcut, we can just count the 5 digits in this number. Ignore the multiplier times 10 to the negative 6 and just look at the coefficient out in front.